Hi there, you're in the lab with your mate JJ. Today is Maxitronix Day. Today we're going to keep on keeping on with our Maxitronix 30in1. We're up to project number 3. My silly job title for today is Chief Fuse Blower. Today I'm the Chief Fuse Blower. I had a look at, ahead, and it's a pretty simple circuit that we're doing today. So that's okay. You got to start somewhere. So what we're going to do is jump over on the computer, have a look at the instructions. I guess we might as well do this circuit up in KiCad, but we won't test it. We'll just design it. It won't take long at all. Then we'll pop over to the booth and we'll assemble the kit and we'll bring it over to the lab and we'll have a look at it. There's not any really sort of dynamic signals in it, so I think we'll just have a look at it with a multimeter rather than firing up the oscilloscope for this one. So let's jump over to the computer together and have a look at the instructions. Here on the computer. Now this is Maxitronix 30in1, project 3 of 30. It's the one-way street. Do you remember what LED stands for? Light emitting diode. And we told you that a diode only lets electricity flow in one direction. Here's proof. Complete the wiring and then touch the two free ends of the long wires together. The LED lights up, right? Now reverse the connections to the batteries and touch the long wires again. Nothing happens because the flow of electricity is going in the opposite direction and the diode won't let it through. In the schematic, you can see how the diode must be connected for it to light. The positive side of the batteries goes to the arrowhead and the negative side of the batteries goes to the line. This would be good information for your notebook. You are keeping one, aren't you? The 680 ohm resistor in this circuit reduces the amount of electricity going to the LED. It can't take very much or it will burn out. A practical use for this circuit is as a continuity tester. It will allow you to see whether electricity is flowing through a particular circuit or component. This kind of testing can help you find where the problems are if a circuit isn't working correctly. Then this is the schematic. We've got a 680 ohm resistor here. We've got a light emitting diode here, and we've got a 3-volt supply here. And this is the wiring sequence for this particular project, which is pretty straightforward. So I suppose we should write it up in KiCad. Let's do that. So this is number 2. So we want to file, new project, and go up here and we'll make it number 3. That looks good to me. All right, so let's open the schematic. All right, so we're just basically going to take that and draw it up in here. Oh, not that. What am I doing? This. Easy peasy, huh? So I think it's A for add. It's taking a while to load all the symbols. All right. All right, so we want to add R for resistor. And we'll rotate it. Which way is rotate? This way. Yes. All right, and we can zoom into the thing. Okay, that's a bit too close. All right. Still learning the tools. All right, let's add LED. There we go. All right. And then we're going to add V. Man, I need to relearn this every time I go to use it. here's a VDC. That sounds good to me. And we're going to want a ground symbol. So I think we add 0. Yes. All right. Now let's add some wires. Is it W for wire? Not sure. W. That worked. What about if I do that? No. Sure. I might just call that. That's good enough for now, I reckon. This should be value 3 volts, and the resistor should be 680. So that's basically our circuit, and if we reverse the polarity, it won't work, which is what we're going to see. So I don't think there's any real way to simulate this that's interesting. So anyway, we did our thing. We drew the schematic for this very simple circuit. So let's pop over to the booth together and let's wire this thing up. All right, so here we are in the booth. The first thing to do is to take the wires out of the old project. We won't even need to time lapse that because that's real easy. In fact, we could probably do the whole thing without time lapse. I'll time lapse it. I'm just gonna follow the simple wiring sequence here. Put the wires in, and we'll be done. All right, so that's all the wires in place. Very simple circuit. We've got these 2 long wires which are going to be touching together. So let's jump over to the bench and we'll see how this circuit behaves. All right. Well, here we are on the bench. Now, I thought that today we might as well just actually use the batteries. So let me just throw you over the other camera and we'll fix this battery situation. All right, so there's some batteries installed in the back of the thing. So we won't need our bench power supply today because we've got batteries. Now, what we want to show is if we touch the wires together, then the LED goes on, and we take them apart and the LED goes off. So that's as we'd expect. And what they asked us to do was to reverse the polarity of the wires. So what we're doing is sending the electricity into the LED the wrong way round. Now when we touch them together, nothing, no light, no nothing. So we should understand that a diode allows electricity to flow in only one direction, assuming it's all within tolerances, of course. So let's just notice that again. There we go, on he goes. Now what I'd like to do is I'll just see if I can find, I'll be back, hang on. All right, I'm back and I found what I was looking for, which is alligator leads attached to some banana plugs. So what we're going to do is put our multimeter here in voltage mode, and we'll put common in there and positive in there. And then let's take some readings. So let's have a look across the diode there. Okay, so we've got a voltage drop across the diode of 1.839. Now, given that we're sending in 3, let's make some notes, huh? What's the date today? It's the 9th of October. Okay, so 9, 10, 20, 25, and this is 30 in 1, number 3, and we've got 3V in, and when we measured that that voltage drop over the LED, it's 1.838. 1.838. We'll just call that VLED. And then I want to know what we're dropping across the resistor. So let's put this in again. And the resistor is 1.277. Call that VR. I had actually intended to calculate this first and prove that we got it right, but we can just do it retrospectively. I've got a calculator somewhere, but those numbers, they look about right to me. 1.8 plus 1.2, that's going to equal 3, but let's see exactly. So what have we got? Come on you come. All right, so we got 1.838 plus 1.277 equals 3.115. Cool. And let's actually just measure it across the battery as well. Okay, 3.130. So 3.115. And it's not actually 3V in, it's 3.13 V in. So that's all very close, isn't it? Looks like there's a tiny little bit extra bit of resistance in some of the wires here that makes up for the difference between this and this. Also, that the meters are probably not that sensitive anyway. Okay, so I think that's everything that we were going to do with this experiment. We proved that the LED only lets the power go one way or the other. We had a look at the voltage drop across the LED and the voltage drop across the resistor. So that was all pretty good. Very simple, humble little project today, but we're learning. That's good. So there was nothing surprising today. And if you're new to electronics, you might still be getting your head around the idea that an LED only lets power go in one direction. It's interesting to see how the power gets used up in the circuit. Anyway, I think that's it. So I'll throw over the farewell cam and we'll wrap up. And that's wrap. So yes, a very humble little circuit there today. Just showing you how diodes allow electricity to flow in one direction and not the other. Very simple. We used our batteries today, so we didn't need our bench supply. Got to try out the old multimeter. That was good, just to get a voltage reading. A couple of them, in fact. Made some notes about that. So yeah, I think that's everything for this project. So that's the end of the video. I hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe.